So next I want to talk about trends. Each year, IFR publishes the 5 trends that from a global perspective, we feel have the most relevance in driving the robotics industry forward. And so for 2026, we've identified the following. First, we know that robots can help address global labor shortages and skill gaps. We've talked about that for a long time. But the trend that we see is that the success really depends on employee acceptance and very strong upskilling programs that need to be in place for employees to continue to accept the automation move. Secondly, we're seeing the convergence of IT and OT, and this is enabling seamless data flow between the digital and the physical worlds. This improves robot performance and flexibility. Next, robots using AI. They've used AI for a long while, but it's becoming more autonomous and more capable, and I'll delve into that a little bit more. Look around at this show for the 4th one. Humanoid robotics is expanding quickly. It's so fast. At the same time, real-world adoption really depends on reliability, efficiency, and compliance with industry standards. And finally, security, data privacy, governance risks are all increasing with all of these trends, and especially with more intelligent AI-driven systems, and there's work to be done. So I'm going to spend a few minutes on each one of those 5 trends. Robots as allies in tackling labor gaps due to demographic shifts. So a few pieces of data. Demographic shifts are leading to declining working age populations in many countries. Not sure I'll be around in 2060, but by 2060 it's predicted that in the OECD area there will be an 8% decline in the working population, with Korea, Italy, and Japan being most severely hit. This population aging could also lead to a dramatic slowdown of economic growth. The GDP per capita in the same region could slow down by about 40% in 2060. So we need to make improvement in productivity gains, which we can do through robotics. This aging population is also going to need to be taken care of. So there will be increasing demand for elderly care and for health care, and many more robots will be needed in the service sector. The attractiveness of manufacturing jobs will change too. Robots reduce routine work and can support new career paths. Data suggests that 3.8 million workers will be needed in U.S. manufacturing by 2033, and up to 1.9 million of those jobs that are needed will be left unfilled. Huge opportunity for our robots to basically go in there and take that on. However, employee involvement is absolutely key to the acceptance in industry and services. And the more robots that we see in density, we believe that that's happening more and more. It will mean that we need to really train our employees. The skilling and also the upskilling of our workers will enable us to adapt to that trend. And there are very strong regional and sectorial differences in that. Next, I want to talk about the convergence of IT and OT, and as this increases, how it increases robotics versatility. In the past, information technology and operational technology data silos have led to disconnection and inefficiencies. OT has been controlling isolated machines, robots, sensors, and processes. IT has been managing data, analytics, and digital systems, and focusing on throughput and visibility. The convergence of IT and OT is really the foundational element of the digital enterprise, Industry 4.0, and this now allows for seamless data flow between the digital and the physical worlds. Connected systems will allow us to scale, adapt, and integrate over time. We'll be able to interact with digital twins, share telemetry with analytics platforms, integrate into enterprise systems, and enable real-time data exchange that can lead to higher productivity. Robots will become cyber-physical systems, and the system design and interoperability will be crucial for these to improve the versatility and capability of our robots going forward. AI. AI is not new to robotics. It helps robotics. We've worked with it for many years. It's helping robotics today to handle variability and unpredictability. It allows us to operate safely and reliably in public spaces. And using analytical AI today allows us to process large data sets, recognizes patterns, and enables predictive actions to take place. As it becomes more capable and accessible, it will become a powerful enabler, making robotics more accessible. Generative AI, autonomously generating intent-based actions and adaptation to new environments, will allow us to save time in coding or in programming our robots, and will go from a shift from rule-based automation to intelligent, self-evolving systems. In the future, we can enable non-experts to deploy and operate robotic systems. We can reduce the need for specialized programming skills, and we can allow a broader participation in automation. Agentic AI, autonomy and goal-oriented, will allow autonomous systems being capable of perceiving their environments, reasoning through complex problems, and planning multi-step actions and adapting to real-time changes. There is a huge impact that we have to address on the way we program, teach, and use robots in the future. Humanoids, as I said, walk the show. There's humanoids all over the place, and it's growing every day. There's tremendous media attention, and large investments are going into humanoid companies, startups, university spin-offs, and also the supply chain that affects them. Component suppliers, motors, drives, arms, hands. Automotive companies like Toyota, Tesla, Chery, XPeng, Mitsubishi are all experimenting with humanoids in their facilities today. The electronics companies and 3C companies fast following suit. It's rapidly expanding, and it's very hard to assess the actual market size today, and credible unified statistics are still missing. However, in our report this year, we will start to make an attempt to put numbers together of humanoid deployment around the world. Huge expectations are applied towards performance and applicability of what the humanoid can do. And what we see right now is humanoids being used mostly in trial applications and prototypes, with the automotive industry really pioneering, as it's done in the past, their use in warehousing and manufacturing segments. Reliability, efficiency, and compliance with industrial standards is going to be critical for real-world adoption, but we have to assume that this will have a huge impact on the traditional robot market. And finally, safety and security in robots. We have huge opportunities available to us with connected AI-enabled robots and humanoid robots. But there are also rising risks that we have to take into consideration. Cybersecurity, data privacy and protection, transparency, accountability, AI model integrity and vulnerability, and not forgetting the physical safety and human interaction risks that have to take place. There will be a demand for governance and for assignment of liability. Safety validation and testing will become more complex, but even more essential. And we have to define and comply with ISO safety standards as we move forward. So thank you for your attention. I'm going to now hand over to Robert, and he will facilitate the panel.